Welcome to ScienceCover.com. Let's start with a Do Now task. Pause the video, link the letters to the numbers and break the code. Let's check our answer to the Do Now task. Sulfur and nitrogen dioxide can cause acid rain. Carbon dioxide causes climate change. In this lesson, we will look at supply and demand. We will focus on patterns in demand, how to supply enough electricity, and the economic cost. Demand is the amount of energy required by a population. This value changes throughout the course of a day, and it also changes over the year. This graph shows the energy demand throughout the course of a day. The red line represents demand during the winter months, and the blue line represents the demand in the summer months. The graph shows that the red line is clearly higher. This indicates that there is more demand for electricity during the winter months. This is due to several factors. Firstly, the winter months are colder, which means there is more use of electrical heating devices. Secondly, the poor weather forces people to stay indoors. This means a higher portion of electricity is used to power televisions, video games consoles, and kettles. Thirdly, in the winter, the sun sets much earlier, which means that there's a larger demand for electricity on lighting. But even over the course of a day, demand changes considerably. At around 6 a.m., it rises as people rise from their beds, switching on lights, TVs, and workplaces open. At about 9 o'clock, the demand stays consistent throughout the working day. In the winter, we see a peak at around 4 o'clock as lights are switched on and people have early evening meals. Throughout the evening, the demand decreases as people make their way to bed. Now pause the video and complete task 1. Let's check our answers to task 1. Describe how the pattern changes from summer to winter. There is a higher demand for electricity in the winter and a lower demand for electricity in the summer. Why does the demand change from summer to winter? In the winter, the sun sets earlier, so lighting gets switched on earlier. The winter is colder, so heaters are switched on. Poor weather results in people indoors, increasing energy demand for TV, gaming, and cooking. Describe the pattern changes throughout the day and why. The demand is low at night, but rises at 6 a.m. as people get out of bed. It stays steady or constant after 9. Then we have a peak in the winter months at around 4 or 5 o'clock as lighting is switched on. Demand lowers in the evening as people go to bed. Let's look at how electricity companies meet the change in demand in electricity. The demand for electricity never drops below a certain amount, even at night. So electricity companies have some power stations that are switched on all of the time, and it is important that they produce at least this amount of electricity consistently. This limits which energy resource can be used, as we cannot rely on wind or solar for this role, as the amount of energy they produce is inconsistent. The power stations that produce the most consistent amount of energy and could fill this role best are fossil fuel power stations and nuclear power stations. However, neither of these are renewable, so both will one day run out. The most reliable and consistent renewable sources could be geothermal, which can only be used in geologically active areas, or hydroelectric power, which could be used in countries where it rains frequently. We also need to select power stations that can be used during the day to fill the higher demand. This must be something that can be switched on during the day, but turned off again during the night. We cannot use nuclear power for this role. This is because it takes several days to start up a nuclear power station and several days to shut the nuclear power station down. Fossil fuel power stations take only a few hours to warm up, so they could be used to fill this role. And hydroelectric power stations can be started up instantly, so they could also be used to fill this role. We sometimes get a spike in demand. This usually happens around 4 o'clock in the winter months, but could be caused by a popular football match on the TV or kettles being switched on after the end of a television program. These peaks must be met by a power station that can be switched on and used instantly. Nuclear power takes far too long to start up, but so does a fossil fuel power station. We can instantly switch on hydroelectric, making it a good choice, or we could use wind power to fill the gap. Using these ideas, we can now select power stations that can help us meet demand throughout the day. The main amount of electricity should be supplied by nuclear and fossil fuel power stations. This should meet the minimum demand. These power stations should be left on all the time, as they take a long time to start up, but they produce a lot of energy consistently. As demand rises into the day, we should switch on fossil fuel power stations or hydroelectric power stations. These don't take a long time to start up, but they do supply a lot of electricity. During periods of peak demand, we could switch to hydroelectric and wind power. These can be turned on relatively quickly and should do a good job. Now, pause the video and complete task 2. Let's check our answers to task 2. During the night time, we might choose nuclear, fossil fuel, or hydro. These supply a stable amount of electricity. During the day, we may switch on additional fossil fuel power stations, hydroelectric power stations, use solar or wind. These can be started up quickly. For a peak in demand, we want something that can be started up instantly, like hydroelectric or wind power. The cost of a power station can be broken into 3 categories. Capital costs, this is how much it costs to build. The running cost, which is how much it costs to run due to its fuel and maintenance. And additional capital costs, which are the cost to close it or shut it down. If we can compare several different resources, in this table, the costs are being compared to the price of gas. We can see that wind power is almost 6 times more expensive than a gas power station, with uranium and coal power stations having large capital costs also. In terms of the running costs, wind power again is the most expensive, but solar power is not far behind. Now pause the video and complete task 3. Let's have a look at the answers to task 3. Why do we have 2 different height bars for wind power? Building and maintaining wind farms offshore has a much higher cost than building them on land. This is due to access and movement of people and parts. Which power station is cheapest to run? Nuclear. If we investigated the capital costs of nuclear power station, would it still be the cheapest option? No. This is because decommissioning the nuclear power station, or shutting it down, has a large cost due to the high levels of radiation and disposal of waste. Which is the most expensive to run? Wind power. Will including the capital costs change the energy source that is most expensive? No, wind power is the most expensive energy to set up.